This video demonstrates the implementation of our theoretical framework to support ad hoc definition of tangible user interfaces. This gesture-based implementation, called TAM, allows users to create tangible systems without having to author any content outside the tangible realm. In this example, the user will create a tangible system to show the reaction between hydrogen and chlorine to form hydrogen chloride. To demonstrate substitution using groups, two hydrogen atoms will be created, so that either one can trigger the reaction with the chlorine. The user must introduce each object to the system, create a group to define a common type between the two hydrogen atoms, and then create a set of rules to create an interaction between a single hydrogen atom and a single chlorine atom. The user can then clarify with the system that they are wanting to use any hydrogen atom, not just that specific one. Here, the user places the new object on the table, opens one of their arms out as if to gesture, here it is. The system then prompts for a name, in this case the user calls it H for hydrogen, and then selects the default color and makes the confirm pose by placing their arms vertically parallel, about shoulder widths apart. They then repeat the process for the second hydrogen atom and then the chlorine atom, so they place the object down on the table, open their arm out as if to gesture, here it is, enter a name, and select a default color, and then place their arms vertically parallel. Since the system doesn't know that the two hydrogen atoms are of the same type, the user needs to define a group for them. To do this, the user places both arms straight out as if to say, here are a group of objects. The system then prompts the user to select which objects are in the group and to enter a name for the group. To create a set of rules to define the chemical reaction as an interaction, the user places both arms down on the table at 90 degrees. They then select which objects will be involved in the interaction. In this case, we only need a single hydrogen atom and a single chlorine atom. The user then confirms the selection by placing both arms parallel. The system then prompts the user to resolve the ambiguity between the single hydrogen atom and the group of hydrogen atoms to which it is a member. The user would like to use any hydrogen object in the interaction, so they select the group and confirm by placing their arms parallel. They then perform the interaction to define the rules. In this case, they place the two objects next to one another and then place their arms parallel. The system then asks them what changes should occur when the interaction takes place. In this case, the user changes chlorine's color to red to indicate a reaction has taken place. The user then confirms by placing their arms parallel. Now you can see that the system has created a set of rules to change the color of the chlorine object when in close proximity of the hydrogen. Since the user elected to use the group that they created, they can use either of the hydrogen objects to trigger the reaction. In this video, we have presented an implementation of our general purpose authoring by interaction architecture, called TAM, as a means of enabling ad hoc generation of tangible user interfaces. For more information regarding the architecture and its implementation, please refer to the paper. Thank you for watching.